Hello my dear students. In this video tutorial, I'm gonna explain you the solutions of the worksheet 3 equilibrium. So the first question, it asks, it gives this reaction. Well, let me write with the red pen. It gives this reaction and it asks to find which condition gives the greater percentage of N2. Let me decrease the size, NO2, so which means going on the reverse direction. First of all, we are taking a look at the reaction type. If delta H is negative, it means that we have plus Q, and plus Q means it is exothermic reaction. So we write plus Q on the right side of the reaction, and we behave it as a molecule. So let's take a look at the temperature. Whenever we increase the temperature, as the temperature are on the product side, in order to decrease the temperature, we need to go to the left side. So the first condition is that we need high temperature and high temperature. It's either A or B. Let's take a look at the pressure. For the pressure, let me take that note in here. For the pressure, we need two main things. One of them is that it is the gas particles that are important, and the second thing is that more gas particles means we have more pressure. For example, if we take a look at the reaction, we have 2 moles. We have 2 moles of the particles on the gas particles on the left side, and we have only 1 because it's 1, it's 2. So if we increase the pressure, the reaction will go towards the place which we have less gas particles. In our case, it's gonna go to the right side because we have only 1 mole on the right side. But the question asks for the favor of the reactant. So we choose low pressure. So the answer is B. Second question, which statement below best describes? We need to make sure that we are carefully checking the questions. The dynamic equilibrium. The answer is C. Why? Because it specifically mentions closed system, and it says that the reactants or products are constant. It's not equal. There is no closed system in here, and there is a changing condition in here. So the crucial thing is that the equilibrium not always means 50-50 on the left, concentration on the right. It sometimes can be 40-60, sometimes 45-55, but at least they should be constant. Like if the 45-55 is equilibrium, if one go to the left side, one should come to the right side, so that we have at the end 45 on the left and 45 on the right side. So the answer is C. It's another easy question, number 3. It says that we are producing ethanol. This is ethanol, this is water gas, and this is liquid. Delta H is given minus 45. It means that the Q is plus and it is exothermic. So we write plus Q on the right side. The question asks, what would increase the equilibrium yield of ethanol in this process? So ethanol side, it means that the right side. We need to we need to make sure we favor the forward reaction. Adding a catalyst. Do not forget that catalyst does not change the shear equilibrium position. Now the second thing is the pressure. As I have discussed previously, for the pressure we take a look at 2 things: the gas particles and the number of gas particles. So we have 1 mole, 2 moles in here, and on the right side we have liquid particles. So we have no liquid particles on the right side, which means that we have more on the left, more particles on the reactant side, and which means that more pressure on the left side than the right side. If we increase the pressure, we need to decrease the pressure according to Le Chatelier, and where there is low pressure on the right side. So this option is correct. Now decreasing the temperature. We know that This is exothermic reaction. If we decrease the temperature, Le Chatelier says that we need to increase the temperature, and the temperature is on the right side. Q is on the right side, so by decreasing temperature, we can shift it to the forward reaction. So the answer is 2 and 3. Number 4, it's another question. This time, nothing is, no chemicals are written, just with the word formation. Delta H is given. Again, it's minus delta H, means that it's plus Q, exothermic reaction. It says that how can the value of equilibrium constant Kc can be increased. So what is Kc? Kc is the products, concentration of products at equilibrium divided by reactants. And it asks for how to increase Kc, which means that we need to increase products. So we need to go towards right direction to increase the Kc. So catalyst doesn't change anything. Pressure, as they are aqueous solution and we have both 1, 1, 1, 1 on the left, on the right side, the pressure doesn't change it. And this is exothermic reaction, yes. If we increase the temperature, the equilibrium will start to decrease the temperature, and decreasing temperature, we need to go to the left side. But the question says we need to increase the Kc, so products. So the answer would be lowering the temperature. So if we lower the temperature, we need to increase the temperature, so we need to come to the right side. Another question with the colors first. The question asks, gives this reaction, equilibrium reaction, and it says the cause of purple color of the equilibrium mixture to become paler. So where do we have more paling? On the right side. So we need to move reactions toward the right side. If we, let's take a look at the pressure. We have how many moles of pressure on the left side? We have 1, 1, overall 2 on the left side. We have 2 on the right side. So the pressure does not change anything because we have same amounts. And another crucial thing in the question, we need to read the question carefully. It mentions that it's exothermic reaction. So we write plus Q in here. If we increase the temperature, the reaction will go toward the left side. So it will become more purplish. But if we decrease the temperature, we need to increase the temperature. So we should go toward the right side. The answer is B. Another easier question, Kc calculations. As we discussed previously, Kc is equal to products divided by reactants. So NO, as we have 2 in here, we put on the top, then chlor 2, then, by the way, make sure that these are gases. For solid, we do not write it. For liquid, we do not write it. And NOCl, again, as we have 2 in the coefficient, we write 2 in here. Question 7, same kind of question. This time, delta H is plus 180, means that it is endothermic, and this is minus Q. So for the endothermic reaction, we need to apply energy in, so we should write plus Q on the left side. So which factors would affect the Kc in this equilibrium? So what affects the Kc in equilibrium? It's clear from what we previously said. Catalyst doesn't change anything. The B is not there because there is a catalyst, and there is no catalyst actually in here. So let's take a look at again. Change in temperature in the absence of catalyst. Change in pressure in the presence of catalyst. Catalyst doesn't change anything. What about pressure? Does the pressure change the Kc? No. Pressure, even though pressure can change the concentrations, but after some time, it becomes equilibrium again. So overall, the temperature does not change. Also concentration too. Imagine we are increasing the concentration of AB. In order to create equilibrium, after some time, this one will decrease, this one will increase. So equilibrium will be there again. So the concentration will not change anything. Question 8. So again, we know that Kc is equal to product concentration divided by reactant concentration. So if if it is 2, it means that it's more, means that we have a lot of products are much more than the reactants. It shows that the reaction is almost complete. So let's take a look at here. The reaction is given in here. What's the difference between this first and second? The Kc for this one is x. In the second one, what did we do? We increased the coefficients by 2 times, so it becomes x squared. We need to remember for the reversing and for the half. What happens whenever we halve the coefficients? What happens when we reverse the coefficients? So if we increase the coefficients 2 times, so the resulting k would be x squared. The next question, which of the following conclusion can be made out of this reaction? We take a look at this number, Kc. Again, Kc is product divided by reactants. 10 to the power minus 41 means it's so small number, which means that our reactants is more than the products, which we can deduct from here that the reaction does not proceed.